Yeah, thank you, Alexandra, and thank you everyone for coming. And I'm going to introduce, two projects I've been working in. And so the first one is about demonstration of low-cost solutions for SME adoption of digital manufacturing, and this project is coming as a support of the bigger project called Shoestring. So here, what we are looking is at how can we demonstrate the use of low-cost technologies as part of digital solutions for SMEs. So in particular, we are looking at the integration of commercially available technologies, how we can use this for digitalization in automation and information, and also how we can also do other things related to SMEs, like condition monitoring, control, and other ones. So I will, the best way to show you this is going through demonstrators that we have done, and then I will go into two other parts of the talk, which relate pretty much of how we engage with industries and some parts of engagements that we have done. So now it's going to be, I think it's 3 or 4 demonstrators. So the first one is about low-cost production environment monitoring. And here we are looking at how can we access production environments without unnecessary interruptions. So what we look is at if we got let's say a PLC based robot, if you want, and we would like to know what's the status of the robots, or to see what's going on in the network where this robot is connected. How can we do that with low-cost technologies? So to demonstrate that, we use Raspberry Pis, which were added with Raspberry Pi's hats that made the connection, the hardware infrastructure connection to, in this case, EtherCAT network. We have also patched these Raspberry Pis with off-the-shelf libraries that make the operating system real-time. And as a result, we were able to communicate and give instructions to the PLC in real time for the, say, robot or something, and also to look at the status of this, having a Raspberry Pi set up as a slave in the network, if you want. So this was basically a way to put the right level of communication to request, if you want, and report what the production cell was doing. In the next one, which is this demonstrator, is all about low-cost monitoring. And we were looking at a way of doing, if you want, a bolt-on solution to monitor manufacturing equipment. In this case, we use a 3D printer, but as a manufacturing equipment, it could be any other piece of equipment. This 3D printer was retrofitted with a bespoke IoT monitoring system that consisted of accelerometers and a low-cost vision system again. We managed to put all these pieces of monitoring together with the built-in sensors that 3D printer comes with. And as a result, we integrated the data collected from both, let's say, subsystems into a cloud. So basically that allows us to do a remote monitoring and to bring the data for doing future analytics. The next slide, this one shows another demonstrator. In this case, is dedicated to inventory tracking. And our aim here is to use, looking at, again, off-the-shelf and low-cost technologies, to use off-the-shelf software libraries that put together with a low-cost vision system. And in this particular case, this vision system is quite similar to the one that we had in the monitoring equipment. Are functioning as a nice solution for tracking parts that a manufacturing company might be having from a supplier. So as you can see in the figure, here in the right-hand side. That on top we can see this small vision system deployed in the Raspberry Pi, and the parts that can come either as individual part. In this case, we have a box in there with the QR code, or they can come together in a tray. And what this system does is it recognizes automatically the QR codes in there, and if the tray has a dedicated place where it can be stored, the system will automatically tell you where you can put a tray. But if it happens that you put a part that is already occurrent and repeated somewhere else, it will suggest you that you can put it together with the rest. And obviously there is a backend built with off-the-shelf libraries, again, at very, very low cost. Some of them are open source. Tell you other features like querying whether there are elements in the storage or what other parts are missing, etc. The other system or demonstrator that we have built relates more to information management, and in this case it's all about digital job cards. So for those who are not familiar, what we're looking here is at the paper, if you want, job cards that are seen in manufacturing companies. This paper card, sometimes called travel card, goes together with a part piece from station to station, telling the operator what to do. And there's also some other information saying what's the material of that part, who's the owner or customer, and if there is any checking or inspection, it's also reflected there. So there you can see an example in the right-hand side. And what we wanted to do in this demonstrator as well is looking at a digital version of this. So if we imagine a digital environment where this application will go, you can see that you could have your part arriving to the operator's table or the station, where it's going to have a QR code or a barcode, doesn't matter much, and then with a reader, you will associate the operator ID, the part that arrived, and the station, and then the operator will have in front of the screen something like what you're seeing now, basically telling you what to do, and allowing the operator also to enter other information, such as, well, I'm starting the shop now, I can put some notes here if something went wrong, and when the operation is done, then saying log out, I just finished, and the part goes to the next station. In particular, this demonstrator has called lots of attention from SME manufacturers who are still using paper-based, and yeah, they are looking forward to see this, a bit more of development. Now, as part of the project, we also had some other engagements with companies. In particular, we talked to other companies who were looking at how to start developing, or how to plan, or how to understand how an Internet of Things solution should look like. So for that, I'm going to show you quite quickly. We have basically gone through the different parts of what an IoT application have at the general level. And for each of them, we went to the different type of sensors that different domains or areas are working with. Together with this, we also had an exploration of the different communication technologies out there, and which are the costs or what should be considered when the communication infrastructure has to be thought and evaluated for deployment. And also together with that, the costs and which are the advantages in different sectors. Like for instance, in smart manufacturing, you will have some technologies, smart farming, sorry, some technologies that work much better than in manufacturing or smart meters. Together with this, we also look at some industrial Internet of Things development kits that basically tells you, if you want to do a prototype of your solution, how do you start putting things together, and how can you show a new product, how can that be evolved into something that a customer would like to have deployed. So all these small kits that are out there are really low cost and can help companies to rapidly put a prototype to see whether it could work as a solution or not. And of course, there are also ecosystems for IoT deployed by different companies, and most of them are like from general purpose IoT platform vendors. And they basically are there to help you bring data that they collect from the field into the cloud and give a nice way for the companies to collect that data, put it in a certain way, and then make visualizations or put it available for the customer. So this is, for instance, an example of Amazon that have all this type of infrastructure that rapidly with different products, they can hook up the pieces of hardware that are collecting signals from sensors and rapidly with all necessary features for security and broker and rules for activating engines and going into databases can help the developer having a prototype. Probably this is my last slide, and it's all about outreach. And this is a summary of what this project had allowed us to do. So we had different workshops with manufacturing SMEs. Demonstrators were shown across different events, from partners meetings to open workshops. Hundreds of people have seen this in advanced engineering last year in Birmingham. We also have, as I was mentioning to some of the demonstrators, industry engagement and looking for them to become pilots. And one of the other things that we were also engaged is with students, and obviously the University of Cambridge, where we have run hackathons, and industry companies had come to the hackathons, and they were part of the judges. So last event that we had was online due to the known circumstances, and it was last weekend. We had about 130 students registered, 25 teams, all competing online during 2 days, and we had an international board of judges looking at the presentation of the students, about 30 presentations, all of them in 2 hours. It was an amazing event. And I think, this is my last slides. Over to you, Alexandra, if there are any questions.
Thank you very much, Herman. I think there were a few. So from David, one of the challenges with any QR-based system is dealing with labels damaged with wear and tear. Does the system reconstruct damaged labels, or is it the users who are maintaining them?
I think at the stage of the demonstrator, we haven't considered things like that. But yet we consider whether the demonstrator could cope with multiple QR codes. So if you see some solutions out there in companies, they usually have a gun and they have to go QR code by QR code. And I think even your phone might be only capable to recognize one QR code at once. I'm not sure, probably my phone is too old. But in this case, when we look at the demonstrator and it was shown to different visitors and partners, they were impressed that they were able to see that different QR codes were recognized at the same time. But yeah, that's a good point. We haven't tested with QR codes that arrive damaged or be blurred or if they are not able to be read properly. But that's a good point to consider. Thank you.
So I had one other comment regarding the hackathons. It seems to be quite a successful part of this project. I guess if any other pitch-in projects are thinking about running hackathons as part of their dissemination or even development activity, perhaps it would be nice for them to see any videos or any output from those so that they could get inspired, I guess.
Yes, absolutely. And that's really good that you put that point out there, because we got, in this last hackathon in particular, we were broadcasting the presentations of the students online in the YouTube channel. And we left the winners, if you want. There were 3 challenges. So the winners of each challenge, we left their presentations for them, for people to watch. And also, well, the award ceremony where you're just gonna have a bit of a recap of what the event was about. But yeah, please do contact me. I'll send you the link of the YouTube channel. But by all means, I think you can Google it, put Shoestring Hackathon, and you will have the suggestions for going straight and look at the presentations. But otherwise, do contact me. I'm happy to share knowledge, or if you need any help to run your first hackathon online or in person. We did in person last year. I'm here.
Thank you very much, Herman. And I think John's raising the point that robotics team have been running hackathons as well.
That's correct. They ran actually some pretty successful hackathons a little while ago, and that report should be public fairly shortly.
Brilliant. Wonderful.